This is actually take two on this video because the previous one I just recorded only a portion of the screen. So let's go. So this is your first intro practice question. We've got about 7 questions that we're going to go through as intro practice questions, and every question in the NSC examination is simply a combination of those 7 questions. So if you've got that down, you should be fine in the exams. But remember, after the 7 intro practice questions, these short little scaffolded ones, you should do about 5 or 6 full Doppler effect questions on your own, and then do hundreds more in order to ensure that you have mastery of this section. Okay, so the question is, the siren of an ambulance has a frequency of 700 hertz, has a frequency of 700 hertz. So we know this is the siren, has a frequency of 700 hertz. You are standing on the pavement. If the ambulance drives past you at a speed of 20 meters per second, right? What frequency will you hear when the ambulance is approaching you and the ambulance is driving away from you? Take the speed of sound to be 340 meters per second. Okay, so let's quickly identify what each of these things are. The frequency of 700 hertz, if that's the frequency of the if that's the frequency of the siren, then we know that that is the frequency of the source. Okay, yeah, let's make that blue. Okay, so that is the frequency of the source. Okay, you are standing on the pavement, so that keyword over there is standing, and if you are standing, that means that your velocity, the velocity of the listener, or rather your speed, is 0 meters per second. Okay, and then if the ambulance drives past you at a speed of that, we know that this is the velocity or the speed of the source. What frequency will you hear when the ambulance is approaching you? And this over here is our V. Okay, so let's move forward. The very first thing you want to do when you get a question, there's only one formula for the Doppler effect. On the formula sheet, it's the frequency of the listener is equal to this bracket, which is V plus or minus VL over V plus or minus Vs multiplied by the frequency of the source. The first thing you do, because you get a formula mark in physical sciences, you write down this formula as you see it from the formula sheet. Once you've done that, then you go and you manipulate it. So let's do question A over here. For A, the ambulance is approaching you. So you're going to write down FL is equal to some fraction, which is our multiplier, multiplied by Fs. And you're going to say, okay, I've got V, but the source is moving, right? So I'm going to have VVS. There's going to be some value for Vs. V and V over here is the same value. It's this constant 340. And now you test your intuition. If the siren of the ambulance is approaching you, it would appear that the sound is getting louder. But when we say louder, what do we mean? Louder than the true frequency, louder than the frequency of the source. And so over here, you're going to put that in, and you're going to say, okay, for the FL to be bigger than Fs, because remember, FL is simply Fs times some number in this bracket, right? And this bracket is a fraction. Now, if this thing is a fraction, in order for this thing to be larger than the frequency of the source, I need this fraction to be bigger than 1. Okay, and if that fraction is bigger than 1, I need the top to be bigger than the bottom. In other words, the numerator to be bigger than the denominator. And for the numerator to be bigger than the denominator, I would make that a minus, okay? Because then the top is bigger than the bottom. So guys, let us go and substitute in actual values. That shows you how to manipulate it. Remember to go back to the 4 cases that we've previously covered. Okay, so the V over here is going to be 340, and this is going to be 340 minus the 20 meter velocity speed over there, multiplied by 700 hertz. Okay, and then you need to put that in a calculator, and once you put it in the calculator, you should get an answer of, we just did it in take 1, 743.75 hertz. Okay, and that's what you should get. Righto. So now let's go to B. Let's go to question B. And again, we write down this formula. It's going to be FL is equal to some bracket times Fs. In the bracket, I'm going to have V, I'm going to have Vs over here. I know that my velocity of the source is 0, and because that is 0, my apologies, not the velocity of the source, but the velocity of the listener, or the speed of the listener, rather. So this is going to be Vs, and the VL, this part over here, this part here is falling away because you are standing on the pavement, right? So VL is 0, so we just leave this as V, and therefore we can go and we can say that if the ambulance is moving away from you, then the frequency of the listener, for this case over here, the frequency of the listener is going to be less than the frequency of the source. And if you want that to be less than the frequency of the source, it means that the fraction over here, the bracket that we are looking at, this bracket must be less than 1. Okay? Righto. So how do we get that bracket less than 1? We're going to say that the denominator must be bigger than the numerator, so you put in a plus over there. Okay. Now let's actually substitute in, guys. I'm going to multiply this by 700. On this side, I'm going to have V, which is 340. And here I'm going to have 340 plus 20. And when I calculate that, I get an answer of 661,11 hertz. Okay. Hopefully we're all together on that. 661,11 hertz. Okay. And so there you can see the examples. And just as a recap, write down the formula as you see it here from the formula sheet, then go and manipulate it. I want you to do it this way, where you can always check that I test my intuition. If something's coming towards me and it is a source of sound, then I'm going to perceive it at a higher frequency than the actual true source. Hence, my fraction here must be bigger than 1. And for a fraction to be bigger than 1, I need the top bigger than the bottom. Simply look at how you can get the bottom to be smaller. That's going to be minus. Here you need the bottom to be bigger. So I want you to reason it out like that. I don't want you to memorize that, hey, when it's approaching me, it's going to be minus. When it's going away from me, it's going to be plus. I want you to reason it mathematically. Okay.